Hi STEM students, welcome to the second day of your video on zero and negative exponents. Your learning target today is to evaluate exponential expressions. And so these first three examples are going to build on what you learned yesterday. First thing I want you to notice on number one is that the zero exponent applies to all of this expression. So the entire value of this expression is equal to 1. All right. Where the next one, only this part becomes 1. So 4 times 1 times 2 gives you 8. And then on number 3, only 6 to the 0 becomes 1. So you're left with 5 plus 1, which gives you 6. So don't just automatically put a 0 in, or a 1 as an answer, when you see a 0. The 0 exponent only affects the base to which it's applied. So really just kind of watch what they're doing. If they're adding, if they're multiplying, you have to proceed with the rest of those operations. All right, my cat's in the way. Move, Roby. Move. There we go. Okay. A lot of the directions are going to ask you to simplify expressions. So what do we mean by that? Well, if you see things like, simple numerical calculations, for example, like 2 to the third, you should replace that with 8. But like 2 to the 14th power, no, don't worry about it because we're not expecting you to use a calculator. So the simple ones, the low exponents like 2, 3, 4, yeah, you should evaluate those. Okay. If you have a negative exponents, you shouldn't leave those in your answer. Make exponents positive by moving them either to or from the numerator and the denominator. And then you can make that exponent positive. So if it's in the bottom of the fraction, move it up. If it's in the top of the fraction, move it down. Again, you cannot have negative exponents in your answer. You cannot have duplicate bases. So you can't have like 4 to the third over 4 to the 7th. We'll learn how to simplify something like that. But the base of 4 shouldn't be repeated. All right. What you see here are just two ways to remember the rule for making exponents positive. I want you to write those two rules out in math form here. So the rules for negative exponents say that if you have a base raised to a negative power, I can rewrite that as 1 over that same base with a positive power. And it's also true that if it's in the denominator with a negative exponent, we can bring it to the numerator and make the exponent positive. All right, so they're really simple rules. They just look weird because you're not used to seeing negatives. So what I would encourage you to do is before you start these problems, go through, use like a highlighter, or you can even box off the base. Anything that has a negative exponent, put a box around it, because that part of the expression will have to get rewritten with a positive exponent. Okay, once you identify that, nothing else has to move. So it's kind of nice that you're only focusing on the parts that are negative or 0 exponents. Oops, I missed one down below. Let's see, these ones here. Okay, so now that you've identified what we need to rearrange, let's go ahead and do that. So here, we're using the rule I wrote down up above right here. We're going to make it a positive exponent by rewriting as 1 over k to the positive 3. All right, 14 is really just using this rule. So it has a negative exponent in the denominator. I can bring it to the numerator and make it positive. That simple. All right, on number 15, I can leave x squared alone, but since y has a negative exponent, we have to bring it down to the bottom, to the denominator. Number 16, I can leave a squared alone, but I have to bring b to the negative 2 up, and then it will become a positive exponent. On number 17, m is going to stay in the denominator, n will move down, and I can make it a positive exponent. But since there's nothing left in the numerator, I have to have a placeholder of 1. On number 18, I can leave 2t to the third, and my negative exponent factors have to be moved to the opposite location. Notice I didn't write the 1 as an exponent. That's because an exponent of 1 is optional. It has the same meaning whether you write it or do not write it. Okay, so we didn't really have to do any calculating there. The next section will ask you to do some computations, and the easiest way to do that is to take the original expression and rewrite it so that there are no negatives. And so in this case, a negative exponent means I can rewrite it in the denominator. And now that I've done that, now I can substitute in this number for my x. So I'm going to rewrite that as 1 over negative 3 to the third power. That means we're doing 1 over negative 3 times negative 3 times negative 3. That gives me a negative 27, so I always bring my negative out front. And that way I realize the entire fraction is negative. Okay. Number 9 is very similar. We're going to do 1 over y to the 5th. And then I'm going to replace the y with a negative 2, which means I'm going to rewrite that 5 times. 2, 3, 4, and 5. All right. Now we simplify. Negative 2 times negative 2 is positive 4. Negative 2 times negative 2 is positive 4 times a negative 2. 4 times 4 is 16 times negative 2 is negative 32. So we'll end up with 1 over 32, make the entire fraction negative since the denominator was negative. On number 10, y to the 0 becomes 1. So 5 times 1 is 5. And then we just have to replace the x with the 3. So we'll get 5 times 3 squared. That means 5 times 3 times 3, which gives us 45. All right. When you look at 11 and 12, I really want you to look carefully at the parentheses. Number 11 does not have the parentheses, so that means when I rewrite this, only the 6 has a negative exponent. So I'm going to rewrite this part first. So we end up with 1 over 6 squared, but the negative from the original problem stays in the front. So we end up with negative 1 over 36. Okay? If you compare that to number 12, the entire base gets moved to the denominator and squared. So here we end up with negative 6 times negative 6, which gives us a positive 36. So you really got to watch that base. If it's grouped, the negative sign goes with it. If it's not grouped, it stays outside. 13 is pretty straightforward. 4 to the negative 2 would just be 1 over 4 squared. 4 squared is 16. That's all you have to do. Okay. Again, the last one, very similar. 1 to the negative 4, rewrite it as 1 over 1 to the 4th. Well, 1 to the 4th is 1. 1 times 1 times 1 times 1 is still 1. 1 divided by 1 is 1. All right. On number 15, very simple exercise. Just pay attention to your negatives. This means it wants us to expand it out. So I'm going to move r to the second down below. And then we can expand it out so we have no negative exponents. So 5 squared would be 5 times 5. Q to the third would be q times q times q. R squared would be r times r. And that's all you have to do. So get rid of the negative exponents first and then expand as many times as the exponent says. So here, 5q to the third means I'm going to write 5q 3 times multiplied by itself. R does not have an exponent. P has an exponent of 5, so we're going to expand that out 5 times. And that's it. Thanks for watching.